Hi everybody and welcome back. So this time we're going to learn about exponential functions. Now for what an exponential function is, it's not that complicated. You simply raise the number 2.718 to whatever your x-axis values are. If you're wondering why 2.718, that's kind of random. It's simply because that number shows up a lot when you're modeling the universe. And so they just made a shorthand for it. Yeah, it is more or less just a scientist variable. Okay, now you see this most commonly, I'm guessing, when you're talking about interest rates, especially that compound interest, that stuff that's like magic to you. You're like, oh, if I have $1,000 now, if I look in 10 years, I've got 1,050. Interest rates are pretty poor now. But compound interest, a lot of different things like that do follow an exponential law. Okay, so we have two charts right here. One is exponentially increasing. That one is exponentially decreasing. Now it's not decreasing to infinity, it's just decreasing down to 0. So if I click this one, I right click it, and I add a trend line, well, I can have an exponential function. Once again, this is blowing up. That doesn't really look that nice. I do the same thing right here. Click my data, right click, add a trend line, and exponential. I can display the equation chart if I want to. So this is y equals e to the x. And the other one is y equals e to the x as well. So it all depends. Really all depends. So it looks terrible. How do we fix this? You guessed it. We scale our axes. Maybe you didn't guess that, but I can't tell. I'm just a video. For all you know, I'm a deep fake by Russia. Who knows? I'm real, I promise you. Okay, so how do we scale our axes? Well, I gave you a realistic example so that exponential increase right here, especially over 10 years, isn't that crazy. However, we're going to figure that. So for exponential function, we're just going to scale this y-axis or the vertical axis to make it look nice. So let's do that right now. We're going to go ahead and scale this data right here, logarithmic scale. And it might be hard to tell that that's better, but it is. It's nice and straight now. And then I can, if I want to, scale my axes. So add trend line, sorry, not scale, add that trend line. So linear doesn't look nice. Exponential looks beautiful. Display equation on chart. Wonderful. Display r squared value on chart. Okay. Fantastic. And if I increase this a little bit, I see some power of 0.1398 in front of x. Cool. So if you put in the r squared value, it's 1 because it's an exponential function. And I didn't actually add anything here. So that worked really well. Okay. Also, as an interesting note, if you look at this equation, which you can, you don't see an exponential function here, do you? What you see is a number, 1.15, raised to some power, increasing powers. And you're like, well, that's not exponential. Exponential is that number, 2.7218. You're correct. However, for it to fit an exponential function, it can do some fun math, and it can change this number to the exponential number, and it just changes the constant up here. So it can still fit this form of equation perfectly. You don't have to worry about that. Okay, let's go ahead, hurry on, and finish the last of our function types, which is logarithmic. Where do you see this? Almost never. Just being super honest, I have never actually had to use this. I mean, I use log functions. It's just I don't usually have to log scale my x-axis. But just in case, here it is. Okay, so for for your logarithmic functions, they tend to taper off. And they're all about what power is it changing by? How big is it growing? What power, like what order of magnitude? So to do this, we just scale our x-axis. So click the x-axis, logarithmic scale. It's a nice straight line. Click this, right click, and add trend line and logarithmic. And once again, we've got that beautiful fit to it. Wonderful. Okay, and as a note, log of 0 or natural log, that's ln, of 0 is always an error. So don't do that. If you have to do something close to 0, do like 0.000001. And then you can keep it on there. But otherwise, don't do that. Okay, but with this, you're done. You've finished all these different equation types. You've now mastered trend lines. Kind of. At least you've got a good idea of what's there and why you don't go with the one that is just the best r-squared value. That is wrong. If somebody says, I fit an 8th order polynomial to my data and it looks perfect, don't slap them, but like tisk them or something. I don't know. Do something, because that's a bad idea. You want to go with the thing that is the simplest while still fitting your data well. You want to be able to take away data and it still fit. If it changes dramatically when you add data or take away data, it probably wasn't the right form of equation. So with that, I'll see you all next time. Hope you enjoyed this. Talk to you later. Bye.